Hi dear students, in this video we are going to learn about mole concept and molar mass. This is a fifth part of the chapter Some Basic Concepts of Chemistry. Some basic concepts of chemistry. Basic concepts of chemistry. This is part 5. Right? So in this video we are going to learn about mole concept and molar mass. The term mole has been introduced by William Ostwald. This is a unit for the seventh basic quantity in the SI system, that is for amount of substance. Mole is a unit which is used for amount of substance. This is a SI unit. The unit mole is used to count the number of entities in molecular level. The word mole has been introduced by William Ostwald. Right? This mole is defined as number of atoms present in 12 grams of carbon 12 isotope. So mole is equal to the number of atoms present in 12 grams of carbon 12 isotope. We can calculate 12 grams divided by mass of one atom of carbon, that is 1.9926 into 10 power minus 23 grams. On simplifying this, we will get 6.02 into 10 power 23, which is known as Avogadro number, indicated with the Na. So Na is known as Avogadro number. So mole is the number of carbon atoms present in 12 grams of carbon 12 isotope. Right? So students, 1 by Avogadro number, reciprocal of Avogadro number is known as avogram. It is known as. Earlier we have done unified mass. One unified mass or atomic mass unit is equal to 1 by 12th part of 1 atom of carbon 12. Mass of 1 atom of carbon 12. So here in the mole case, that is mole is equal to 12 divided by 1 atom of carbon 12. But here in the case of AMU, mass of 1 atom of carbon 12 divided by 12 they are putting, means that Avogadro number and unified mass are the reciprocal to each other. So we can write 1 by Na is equal to 1U, right? Or we can also write it as 1 by U is equal to 1U is equal to Avogadro number. Then if we take the product of Avogadro number and unified mass, that we will get it as a 1, right? The product of Avogadro number and unified mass, we will get it as a 1, right? Students, number of moles can be calculated from the formula number of moles is equal to given weight divided by, if it is a molecule, molecular weight molecular weight, right? If it is atoms, given weight of the atoms divided by atomic weight we have to put, right? So number of moles when the weight is given weight divided by molecular weight. If it is for the atom, given weight of atoms divided by atomic weight of that particular element. And when the volume of the gas is given, number of moles can be calculated by volume of gas in liters at STP condition divided by 22.4 liters, 22.4. So we know from the Avogadro's law, 1 mole of any gas occupies 22.4 liters. To calculate the number of moles, when the gas volume is given in liters, provided that is at STP condition, that divided by 22.4. For example, volume of the gas, if the volume is in ml at STP condition, right, that divided by 22,400 will give us number of moles. Here STP is standard temperature and pressure. Standard temperature and pressure. Standard temperature and pressure. Temperature is 273 Kelvin and pressure is equal to 1 atm, 1 atmospheric pressure, right? So when the number of particles is given, then number of moles can be calculated from given number of particles divided by Avogadro number will give us number of moles, right? Students, there is a 3 different formulas to calculate the number of moles. Number of moles is equal to, when the weight is given weight divided by molecular weight, it is for the molecules. Given weight divided by atomic weight, right? Number of moles is equal to, when volume of the gas is given at STP condition, so given volume of the gas in liters divided by 22.4. If the volume is in ml at STP condition, that divided by 22,400. When the number of particles is given number of particles divided by Avogadro number will give us number of moles, right? So students, for example, volume is given at some other temperatures, right? So like some pressure V1 is given, right? And temperature is T1. This is volume is given at one certain conditions, at a certain pressure and temperature is given. Then we need to convert that into the volume at STP condition. P2 is 1 atmosphere. V2 is how much we need to calculate, and T2 will be 273 Kelvin. So by using ideal gas equation, we can use the formula P1 V1 by T1 is equal to P2 V2 by T2. When the volume is given at other conditions, okay, at of temperature and pressure, then we need to convert that volume at STP by substituting the values in the P1 V1 by T1 is equal to P2 V2 by T2. Dear students, if it is given as 1 gram atom, 1 gram atoms means which is same as 1 mole of atoms. Okay, if they are asking to calculate the number of gram atoms in a compound, means that is same as the number of moles, right? So 1 gram atoms is equal to 1 gram atoms is equal to 1 mole of atoms. If it is given as 1 gram molecules, 1 gram molecules is the same as 1 mole of molecules. 1 mole of molecules. Okay. For example, if they are asking a question like how many gram atoms are present in 0.9 grams of H2O is a question, right? How many gram atoms of oxygen are present in 0.9 gram of water, right? Then we can calculate the number of moles of water first. Number of moles of water is equal to, that is 0.9 is a given weight and its molecular weight is 18, right? So which we can simplify it as 9 divided by 18 into 10, right? 9 ones are 9 twos are, that is 1 by 2 is 0.5. Okay, 0.5 divided by 10 is 0.05 moles we are getting. Students, when we take one water molecule, it has one oxygen atom. Okay, number of moles of water and the number of gram atoms of oxygen, it is same, right? Because one molecule of water contains one atom of oxygen, right? Then the number of gram atoms of oxygen is equal to same as number of moles of water, 0.05 we are getting, right? Next, let us discuss about the molar mass. Next, we will discuss about the molar mass. Molar mass is mass of 1 mole of atoms or molecules. Molar mass is defined as mass of 1 mole of atoms or molecules. Students, for example, if you take H2SO4 molecular weight, we know that is a 98. Relative molecular weight we are considering. So that indicates it is a 98 U, right? Unified mass. When we are taking molar mass of H2SO4, molar mass of H2SO4 is 98. U value we know 1.66 into 10 power minus 24, right? So molar mass is 1 mole of atoms or the molecules, right? So 1 mole of atoms is, that is same as Avogadro number, right? And the unified mass and Avogadro number both are reciprocal to each other. So we will get finally the molar mass of sulfuric acid as 98 grams. Okay, we can also call it as a gram molecular weight. The molecular weight expressed in the grams, that is called as a gram molecular weight. Similarly, if you take atomic weight of magnesium, it is 24. When we are talking about a molar mass, the magnitude will be same, we will get a magnitude is 24, but here in the molar mass the units will be grams. Similarly, if you take molecular weight of acetic acid CH3COOH is 60, then molar mass of acetic acid, molar mass is equal to 60 grams, right? That is molar mass is nothing but gram molecular weight, right? Students, next let us discuss about percentage composition. Percentage composition of an element. Percentage composition of an element. Percentage composition percentage composition of an element is equal to mass of an element. That is, we can take a total mass of the element in a given compound, that is should be in the grams, divided by molar mass of the compound, multiplied by 100. Percentage composition of an element is, students, for example, we will take a CH4. Dear students, for calculating the percentage composition of an element, we will take a CH4. Simple example we are taking, right? CH4. Molar mass of CH4 is carbon 12 plus 4 oxygens, 4 into 1, which is a 16 grams we get, right? So let us calculate the percentage composition of the carbon. Percentage of the carbon is only one carbon atom is there. Atomic mass is 12, that is in the grams. 12 grams divided by total mass of the compound is 16 into 100, right? This is also in the grams. Molar mass we need to substitute. 4 3s are 4 4s are, right? 4 1s are, this is 4 2s are, 4 5s are, right? So percentage of carbon we are getting in the methane 25 to 3 is 75%. Then remaining only 2 elements are present. So then this will be, hydrogen will be 25%. Students, let us take one more question for the calculation of percentage composition of an element. Caffeine contains 28.9% of nitrogen by mass. And each molecule of caffeine contains 4 nitrogen atoms. Calculate the molecular weight of caffeine, right? So students, we will use a percentage composition of an element to solve this question. Caffeine contains 28.9% of nitrogen by mass, and each molecule of caffeine contains 4 nitrogen atoms. Calculate the molecular weight of caffeine, right? So percentage composition of nitrogen is 4 nitrogen atoms are present. Each nitrogen mass is 14, right? In the grams we need to put here, right? In the denominator, molecular weight of the compound, it is unknown. Molecular weight into 100, right? Percentage of nitrogen in the sample, the molecule they have given it as a 28.9. Let us substitute here. 28.9 is equal to 4 into 14 divided by molecular weight value. We need to find out molecular weight into 100, right? Transfer molecular weight to the opposite side and 28.9 to the other side of the equation, right? Then we will get a molecular weight is equal to 4 into 14 divided by 28.9 into 100. Okay. On simplifying this, we will get a molecular mass as 194. So students, this is about the mole concept and what is the number of moles, how to calculate the number of moles and molar mass, and finally we learned about the percentage composition of an element. Right? Thanks for watching.